SpaceX has reached a strange point in its evolution. A paying customer can show up with a satellite, tens of millions of dollars, and a willingness to launch. And SpaceX may still have a better use for the rocket. Launch its own satellites instead. By 2026, roughly 4 out of every 5 Falcon 9 missions were carrying Starlink payloads for SpaceX itself. Several outside space companies have reportedly been told Falcon 9 capacity is effectively booked until 2028 or 2029. That sounds like a supply problem. It's actually something far more interesting. SpaceX built a business where the rocket company creates demand for the satellite company, and the satellite company creates demand right back for the rocket company. That loop may matter more than any single rocket SpaceX has ever built, and competitors are finding it almost impossible to copy. For most of the space industry's history, launch behaved like a high-end project business, not mass transportation. Build an extremely expensive machine. Wait for a customer with an extremely expensive payload. Launch it, then build another machine. Low volume made that economically brutal. Fewer opportunities to improve. Less manufacturing repetition. Less operational data. Less chance to spread engineering costs across more missions. SpaceX attacked the obvious problem first, the rocket itself. In December 2015, Falcon 9 successfully landed its first stage after an orbital mission. Then, in 2017, SpaceX successfully flew a previously used Falcon 9 booster again. The usual explanation is that reusable rockets make access to space cheaper. And that's true. Reusability allows SpaceX to refly some of the most expensive parts of the rocket instead of throwing them away after every mission. But that explanation misses the more important shift. Reusability doesn't just change cost, it changes repetition, and repetition creates cadence. Think about the difference between building a prototype and running a factory. One proves something can work, the other learns how to do it again, and again, and again. In 2025, Falcon 9 flew 165 missions. That's roughly one launch every 2 days. And every extra mission produces something that never shows up on a rocket specification sheet. Experience. Launch crews repeat the process. Recovery teams repeat the process. Boosters return, get inspected, and fly again. Ground systems process another mission. Manufacturing gets another cycle of feedback. The system learns. This is where the advantage starts to compound. A competitor can design a reusable rocket. It might even land one successfully. But to accumulate the same operational learning, it needs one thing above all: a lot of launches, which creates a genuine chicken and egg problem. You need customers to build cadence, but customers prefer providers who already have proven cadence. So how do you break that loop? SpaceX found an unusually powerful answer: become your own customer. In 2019, SpaceX began deploying Starlink at scale. At first glance, Starlink looks like a separate business. Falcon launches rockets, Starlink sells connectivity, but economically the two fit together almost perfectly. Starlink needs enormous numbers of satellites in orbit. Those satellites create enormous demand for launches, and SpaceX owns the launch provider. So instead of waiting for outside customers to fill its schedule, SpaceX can generate missions internally. Starlink's share of Falcon 9 missions climbed from about 54% in 2020 to roughly 79% by 2026. And SpaceX isn't launching those satellites just to keep its rockets busy, because Starlink has become the economic engine on the other side of the system. Starlink generated about $11.4 billion of revenue in 2025, roughly 60% of SpaceX's total revenue. The traditional space and launch business, by comparison, generated around $4 billion. That changes how you should think about a Starlink mission. It isn't simply another launch expense. It's the deployment of infrastructure designed to support revenue long after the rocket has already landed. An outside customer pays SpaceX once for one launch. Starlink turns that launch into infrastructure supporting recurring revenue for years. Now, put the pieces together. More reusable launches create more launch capacity. More capacity puts more Starlink satellites into orbit. More satellites expand the network. More network capacity allows SpaceX to serve more connectivity demand. That revenue supports more satellites, more infrastructure, and continued development of the launch system, which creates more capacity. And the loop starts again. Rocket, satellite, customer, cash flow, rocket. This is the SpaceX flywheel, and there's a second advantage hidden inside it. SpaceX controls both sides. It doesn't have to negotiate every Starlink launch with an outside launch provider. It can coordinate satellite design with launch capability, launch timing with network expansion, rocket development with Starlink's future requirements. An improvement on one side can make the other side more valuable. Business strategists have a fairly ordinary phrase for this: vertical integration. But what SpaceX has built is unusually powerful because it doesn't just own the infrastructure, it increasingly owns the demand that keeps that infrastructure running. Now imagine you're a competitor. Building a reusable rocket is already difficult, but matching SpaceX means solving several problems at once. You need a reliable rocket. You need enough customers to fly it frequently. You need enough capital to survive while you build that cadence. And if SpaceX's advantage partly comes from launching its own constellation, you may also need a major business sitting above the rocket that can consume all that launch capacity. That's a much higher bar to clear. At least 7 spacecraft companies have reportedly been told Falcon 9 is fully booked for some types of missions until 2028 or 2029. SpaceX's capacity has become scarce enough that the company can face a real choice. Give a launch slot to an external customer, or use it for SpaceX itself, and those choices don't necessarily carry equal economics. An external mission generates launch revenue. An internal Starlink mission adds infrastructure to a network already generating billions of dollars a year. For some missions, that can make the internal use of scarce launch capacity more valuable than selling the launch to somebody else. And that produces a counterintuitive result. Reusable rockets don't automatically mean SpaceX has to keep lowering launch prices. If capacity is scarce, and SpaceX has a higher value internal use for it, the opportunity cost of selling that launch can actually rise. The rocket isn't just transportation anymore, it's shelf space. And SpaceX owns the product it most wants to put on that shelf. This is why Starship matters far beyond Mars. SpaceX is developing Starship as a fully reusable system capable of carrying more than 100 metric tons to orbit. So the goal isn't simply build a bigger rocket. It's creating a much larger unit of launch capacity. And a major early use for that capacity is expected to be the next generation of Starlink. SpaceX's upcoming V3 Starlink satellites are designed to deliver roughly 10 times the broadband capacity and data density of the current generation. The company ultimately plans to carry as many as 60 of them on a single Starship mission. If Starship reaches reliable, high-frequency operation, the flywheel gets dramatically larger. More payload per mission, more network capacity deployed at once, more revenue-generating infrastructure in orbit, and potentially lower marginal launch costs. Falcon 9 proved the loop could work. Starship is the attempt to scale it. There's a real danger in systems this tightly connected. The pieces stop being independent. If Starship can't achieve reliable reuse and high cadence, SpaceX loses part of the capacity expansion it's counting on. If Starlink growth slows, the internal demand supporting the system becomes less powerful. Satellite deployment also depends on regulatory approval, something SpaceX doesn't fully control. And if SpaceX keeps reserving more capacity for itself, outside satellite companies gain an even stronger incentive to support competing launch providers, potentially strengthening exactly the competition SpaceX has spent years outrunning. SpaceX has acknowledged this tension in its own prospectus. The company may prioritize its own payloads over additional government or third-party customers. So, vertical integration is both part of the moat and part of the risk. The stronger the loop becomes, the more tightly every piece depends on every other piece holding. SpaceX's breakthrough was never just learning how to land a rocket. The deeper breakthrough was turning rockets from occasional projects into infrastructure operating at extraordinary frequency. Then SpaceX did something even more powerful. It built a business that desperately needed that infrastructure to exist. Falcon gives Starlink a path to orbit. Starlink gives Falcon constant demand. More launches improve the launch system. A stronger launch system makes the satellite network easier to expand, and a larger network creates even more reason to launch. That's why the advantage is so difficult to copy. A rival doesn't just need a better rocket, it needs the entire system built around the rocket. Which leads to a lesson that has almost nothing to do with space. Sometimes the strongest moat isn't owning the best product. It's owning the demand that makes your product stronger every time you use it. That's the flywheel SpaceX built. Now everyone else has to find a way to catch it.